Examples of energy can be found all around us. Nature is full of energy, from the power of running and falling water to the electrical power of lightning. Our shorelines are battered by waves. New land forms as volcanoes release hot molten lava. Winds whip around mountaintops. Impressive rock formations are carved by a mixture of sand and wind. Mountains that were once as tall and majestic as the Rockies are worn down by millions of years of wind and water erosion. The surface of the planet is in constant change due to the energy of nature. Animals need energy to survive, to run, play, and hunt. Energy is used by people to warm their homes, cook their food, light their way, and to make it through their busy days. But what is energy, and where does it come from? That's what this program is all about. It's all about energy. To a scientist, work is only accomplished when a force moves an object some distance. A force is defined as a push or a pull. So even though someone may appear to be working hard to lift a weight, if the weight never moves, no work has been done. In contrast, if someone picks up a pencil and moves it to a new location, work has been done. Scientists use the formula work equals force times distance to calculate the amount of work accomplished. Naturally, to do any work requires energy. Energy is defined as the ability to do work. In the metric system, the Newton meter, or joule, is used as the unit of measurement for work or energy. So, if someone moves something with a mass of 20 newtons, 1 meter, he or she is doing 20 Newton meters of work. Remember, work equals force times distance, or 20 Newton meters. Energy is the ability to make things happen. It's the ability to do work. It isn't difficult to look around and see all kinds of examples of energy. Bulldozers need energy to lift heavy loads. The fuel that the bulldozer burns provides the necessary energy. Animals need energy for just about everything they do. Their energy comes from the food they eat. All plants and animals need food to live. Plants are the only organisms that can make their own food. They need the sun to do that. So when we eat food, we are really using the energy from the sun that was stored in the plant. Almost all the energy on Earth comes from the sun. The sun's energy travels 93 million miles, or 149 million kilometers, through the emptiness of space to reach our planet in the form of light, heat, and other forms of energy. The sun is important to all living things on Earth. Plants use the sunlight, water, and minerals from the soil to make food in a process called photosynthesis. Animals depend on the plants. Some animals eat them to get energy, while other animals eat the plant eaters to get energy. The process of energy transfer from the sun to plants to animals is called a food chain. Some animals, such as humans, eat both plants and animals for food. The food is used by the body to do things, such as exercise, work, and just move. Food is chemically broken down and mixed with oxygen to release the energy needed to do things. The amount of energy food contains is measured in calories, and a special piece of equipment is used to determine this. A sample of the food is burned inside a sealed container, which captures the heat energy released and uses it to heat a known amount of water. The temperature before and after burning the food is recorded and then used to figure out how many calories of heat energy are released by the food. Our bodies need a certain amount of these food calories to operate throughout the day. If you aren't active and just sit around, the extra food calories are changed to fat for use later. Remember that most of the energy of our planet actually comes from the sun. Food contains stored energy from the sun. Even the gasoline that cranes, trucks, and cars use has energy from the sun stored in it. These fuels come from fossil fuels that were formed over millions of years. During prehistoric times, the plants soaked up and used the energy of the sun. Then these plants died and were buried beneath huge layers of earth over a long period of time. These plants changed into natural gas and oil, which are then mined and made into fuels for our machines. Energy changing from one form to another is behind everything that happens. Scientists refer to two kinds of energy, potential and kinetic. Potential energy is stored energy, or energy of position. If a book is lifted to the edge of a table, it has potential energy. Someone has used muscle energy to lift the book against gravity to the height of the table. The potential energy is stored energy waiting to be released. If the book falls, it will hit the floor with a force, causing a loud sound, and if someone's foot is in the wrong place, a great deal of pain. The book falling is an example of kinetic energy, or the energy of motion. On a roller coaster, the first hill is always the highest. A huge motor is used to pull the cars to the top of this hill. This represents a great deal of potential energy because the motor has used energy against gravity to lift the car and the people inside. When the coaster cars go over the top of the hill and head down, the potential or stored energy changes to kinetic or energy of motion. The first hill has to be the highest so that the greatest amount of potential energy can be stored up in the cars. A battery has chemical potential energy. The chemical energy is stored until the battery is attached in a circuit. Then the chemical energy is changed to electrical energy. In this circuit, it is used to light a bulb. Wood has stored chemical energy as well. When the wood is set on fire, we see the release of this energy as light and heat energy. The light and heat energy moves from one place to another. So they are examples of kinetic energy, energy of motion. Energy can appear in many forms, and it can change from one form to another, just as the chemical energy of a battery can change to the electrical energy needed in the circuit to light the bulb. The bulb gives off light and heat energy. There are 7 main forms of energy: mechanical, heat, chemical, radiant, electrical, sound, and nuclear. Sometimes energy can be made to change from one form to another instantly. Here is a solar cell panel. The solar cells on it can change sunlight into electricity. When we expose the panel to sunlight, electricity is produced immediately. Notice the needle on this voltmeter moves as sunlight strikes the panels. The voltmeter is indicating that electricity is produced. At a fair, we could find many examples of energy. The lights are examples of electrical energy changing to heat and light energy. We hear the sounds of the rides, and that too is a form of energy, sound energy. The moving parts of the rides are all examples of what is called mechanical energy. The food sold at the fair is cooked with heat energy. When we eat the food, our bodies change the chemical energy stored in the food to other forms of energy, to move our bodies or let us create our own sound energy. Mechanical energy is the energy of motion. Water rushing down a stream is an example of mechanical energy. The blowing wind and running people are examples of mechanical energy. Heat energy is related to the movement of the particles that make up matter. These particles are called atoms, and they are always moving. The movement of atoms causes heat energy. The faster the movement, the more heat energy is produced. You can feel heat energy if you rub your hands together quickly. The mechanical energy of rubbing your hands changes to heat energy. Chemical energy is stored in fuels, such as charcoal, gasoline, and even food. When we burn charcoal in a grill, the stored energy is released as heat energy to cook our food. When we eat the food, the chemical energy stored in the food is used to power our muscles. In another example of chemical energy, a rocket burns fuel and uses it to launch off the ground. Electricity is used every day in our homes to power tools and equipment. Electricity is the movement of electrons. Electricity is considered a secondary energy resource because it is generated by using primary energy resources. At most power plants, steam is forced past turbines that will spin a drive shaft that turns a coiled wire inside a magnetic field. When a coil of wire spins in a magnetic field or a magnet moves in a coil of wire, electricity is produced. Magnetism can be used to produce electricity. To make the steam to spin the drive shaft, a furnace burns fossil fuel to heat water. Or at a nuclear power plant, a nuclear reaction is used to heat up water. In either case, electricity is one of our least expensive forms of energy. Radiant energy includes light, X-rays, and radio waves. Radiant energy in the form of light is critical to life on Earth. Green plants depend on light as a major ingredient in photosynthesis. Photosynthesis is the food-making process upon which green plants depend. During photosynthesis, carbon dioxide, minerals, water, and sunlight are used to make food in the form of glucose, which is sugar, and to release oxygen. Plants are the food makers of our world. In addition, they release oxygen, which is critical to survival on our planet. Nuclear energy has to do with the nucleus or center of an atom. When this center splits, it releases a large amount of energy. This is called fission and is what happens at a nuclear power plant. When atoms join together or fuse, they also release energy. This is what happens on the sun as hydrogen atoms join to form helium atoms, and tremendous energy is released. This process is called nuclear fusion. The law of conservation of energy states that energy cannot be created or destroyed, but only converted from one form to another. Some energy may be lost to friction and air resistance, but the overall amount of energy stays the same. Most energy conversions are not very efficient. There's always a loss of useful or usable energy. A perfect energy conversion is impossible because this means that all the energy in the conversion would be turned to useful work. For example, a car is about 22% efficient, as much of the energy changes to heat and is used to overcome friction and inertia. The human body uses food as its fuel source. The chemical energy is converted to energy to help us move, breathe, think, and carry on all the other important functions that keep us alive. However, the human body is not very efficient, and during this conversion, 95% of this chemical energy is converted to heat. Think of the last time you were very active and produced a lot of heat as a result. Remember, energy cannot be created or destroyed as it is converted from one form to another. Here is an example. Look at this setup of 5 metal balls hanging from strings of the same length. The balls are all exactly the same. What do you think will happen if we lift one ball and then release it? If you thought that only one ball from the end would pop out, you're correct. Notice that it goes up almost as high as the first ball and then swings back, hitting the group and sending the first ball flying again. Each time, the height that the 2 balls reach is lower until, eventually, they would stop this movement. This back and forth movement doesn't continue forever because energy is being changed to heat due to friction and air resistance. Now, let's change things a bit. This time we will release 2 balls from one side. What do you think will happen? Pause the program and make your prediction. As you can see, 2 balls from the other side bounce out. Scientists call this the law of conservation of energy, which simply means energy is neither created nor destroyed. It is transferred or changed from one form to another. Let's try another setup. This time we will release 3 balls from one side. There are only 2 balls left hanging straight down. What do you think will happen this time? Pause the program and make your prediction. Were you surprised by what happened? One of the balls joins the 2 so that the amount of kinetic energy is equal. Now let's change things by releasing 1 ball from each side at the same time. Pause the program and make your prediction. Did you expect the balls to bounce back out? As long as the strings don't get tangled, you could do this with different numbers of balls. When we lift a ball to a certain point before dropping it, we have given it potential energy. Someone has used his or her muscles against gravity to lift the ball to a certain height. When the ball is released, it begins to swing down. The potential or stored energy is changing to kinetic energy, or energy of motion. When the ball hits the group of balls, the energy is transferred or moved from one ball to the next until the ball on the end is pushed into the air against gravity. This ball reaches a certain height and stops. At that point, it has potential energy. Then it begins to swing down, which means its potential energy is changing to kinetic energy. Look at this amusement park ride and think about how it might be another example of potential energy changing to kinetic energy, and then kinetic energy changing to potential energy, and so on and so on. How much kinetic energy an object has depends on 2 things: how much mass the object has and how fast the object is moving. Forms of energy are all around us. There are many sources of the energy we use every day. These sources of energy fall into 2 groups called non-renewable and renewable resources. Most of the energy used in the United States comes from non-renewable resources. These resources are called non-renewable because once they are used, they cannot be replaced. Coal, petroleum, natural gas, propane, and uranium all take millions of years to form. Their supply is limited, and eventually they will run out. Coal, natural gas, petroleum, and propane are referred to as fossil fuels because they have formed over the millions of years since prehistoric times. These resources formed from the tiny plants and animals that lived before the dinosaurs. These plants and animals got their energy from the sun. When they died, they sank to the bottom of swamps and oceans. Then, over millions of years, water and dirt piled up on these plants and animals. The pressure caused chemical and physical changes that transformed these decayed plants and animals into fossil fuels, which have become so important to our life. However, once the supply of fossil fuels is used up, it will be gone forever. Here is a chart that shows energy consumption by source in the United States. Notice how the non-renewable resources dominate, with 94% of energy consumption coming from their use. Giant machines are used to remove coal from the ground. There are 2 methods for mining coal. Surface mining is currently the most widely used method. This method can be used when the coal is a few hundred feet below the surface. Giant machines are used to scrape the topsoil and dirt away, and then the coal can be mined on the surface. Underground mining is necessary when the coal vein is deep underground. In this situation, people and machines are transported underground to remove the coal. 91% of the coal mined in the United States is used to produce electricity at power plants. Coal is also used in the manufacture of paper, cement, and bricks. Our coal reserve should last for the next 300 years at the current level of use. Before any coal is mined from an area, the coal company plans with the local community and other interested parties how to reclaim the land. Coal companies make a great effort to treat the land in an environmentally proper fashion. Sometimes coal contains sulfur, which is released when the coal is burned, and this sulfur combines with oxygen to make acid rain. Acid rain can harm trees and other living things, so coal companies try to locate sources of coal that are low in sulfur. They also remove sulfur from the coal they mine. Power plants have installed scrubbers in their smokestacks to remove the sulfur before it can get into the air. Natural gas is the cleanest burning fossil fuel. Natural gas is used mainly for heating. It is used primarily by industries as a fuel for heating and the manufacture of products. It is also an ingredient in products such as glue, fertilizer, and paint. Natural gas, like other fossil fuels, was formed millions of years ago from dead plants and animals. Natural gas is found trapped in underground rock pockets. It is considered a non-renewable resource, though some natural gas is generated and can be collected at landfills as garbage breaks down. The main gas associated with natural gas is methane, which is colorless and odorless. Natural gas companies add the odor of rotten eggs to natural gas so that if there is a leak, people can tell there's a problem. 60% of homes use natural gas for heating. It is estimated that the United States has about 50 years of natural gas left. Petroleum is often referred to as oil or crude oil. It is a fossil fuel and is a very valuable energy resource. Petroleum is primarily used as fuel for vehicles used for transportation. To bring petroleum to the surface of the earth, oil companies drill deep wells. 1/4 of the Earth's petroleum reserves are from offshore wells located in oceans. Most wells are about a mile or 1.6 kilometers deep. The oil that comes out of the ground must be cleaned up. It is sent to a refinery where it is separated into many fuels, such as gasoline, diesel fuel, jet fuel, and heating oil. The United States only produces enough oil to serve about 1/3 of its petroleum needs. So most of the petroleum used in the United States is imported from other countries. Propane is a gas that can be found with natural gas and petroleum deposits. Propane is a very clean gas. In fact, it is used as the fuel in forklifts that must work inside warehouses. This fuel doesn't give off harmful or deadly fumes, so it can be used inside this closed area. Propane is also used by homeowners to power barbecues, and in rural areas it is often used as the fuel to heat homes. There are many sources of the energy we use every day. These sources of energy fall into two groups called non-renewable and renewable resources. Renewable energy resources can be replaced, and in some cases are considered to be limitless. Examples of renewable resources include solar, wind, geothermal, biomass, and hydropower. Solar energy, or the energy from the sun, is responsible for most of the energy on Earth. The sun produces this tremendous energy as a result of nuclear fusion occurring in its interior. During nuclear fusion, hydrogen atoms combine to form helium atoms. Every time hydrogen atoms combine to form helium atoms, a great deal of energy is released. This energy radiates out from the sun in all directions. Actually, only a very small part of that energy, about 1/1000th of the radiant energy released from the sun, strikes our atmosphere and planet. Yet that solar energy is critical to the survival of all living things on our planet. Solar energy drives the food-making process of green plants, called photosynthesis. Green plants take carbon dioxide from the air, water and minerals from the ground, and the light of the sun, and in the presence of chlorophyll in their leaves, produce food in the form of sugar or glucose. In addition, the plant releases oxygen as a byproduct of photosynthesis. So in many respects, all living things on Earth owe everything to the light from our sun. Many homes take advantage of solar energy by facing their windows in such a way as to take advantage of the thermal energy of sunlight to heat rooms naturally. A solar cell can be used to convert sunlight directly into electricity. Solar panels on this experimental aircraft power the electric motors that enable it to fly. Wind turbines can be used to generate electricity. The wind turbine spins in the air and is connected to a generator, which produces electricity. This is a very clean method for generating electricity. There is no waste product, and the only requirement is a steady movement of air provided by the wind. Geothermal energy. Geothermal energy is the energy of the earth. Geo means earth, and thermal means heat. This energy is created about 4,000 miles or 6,400 kilometers beneath the Earth's surface. Temperatures are extreme at this depth. Wells can be drilled to pump water heated by this energy to the surface to be used at geothermal power plants. This hot water is used to change water into steam to spin turbines and generate electricity. The active geothermal areas are found around plate boundaries. This is where earthquakes and volcanoes occur. Geothermal energy is considered to be a renewable energy source because the interior of the Earth is always hot, and all that is needed is a supply of water so that steam can be formed. Biomass is anything that was once alive. Wood, agricultural crops, and animal products are all examples of biomass. Biomass gets its energy from the sun. Through photosynthesis, plants make sugars. These sugars are used as fuel by living other things. The energy stored in plants can be used as fuel. For instance, before 1850, wood burning was the main method of heating homes and cooking foods. Today, wood burning represents a small part of the energy sources in the United States. Another biomass source of energy through burning is garbage. Garbage can be burned to generate electricity in a plant called a waste-to-energy plant. Garbage produces only about 1/4 the energy that an equal amount of coal produces, but there seems to be an endless supply of garbage, whereas coal is a non-renewable resource. When dead animals and plants decay, they give off a gas called methane. Bacteria are responsible for this decay. Methane is a good source of energy. At landfills, wells are drilled to capture the methane gas given off by the garbage and decaying waste. If yeast, which is bacteria, is added to biomass, a fuel called ethanol can be made. This process is called fermentation. This fuel can be mixed with gasoline to power automobiles. Hydropower is the use of running water to generate electricity. A hydropower dam can be built on a river. A reservoir can be used to store the energy. Opening and closing gates can control the flow of water through the dam. Turbines in the dam turn when water rushes past them. The turbines are connected to the drive shafts of generators, which generate electricity when they spin. This is the least expensive method for generating electricity. Throughout the world, it accounts for 25% of the electricity produced. In the United States, it accounts for between 5 and 10% of the electricity produced. It is non-polluting, and because our water is constantly replenished through the water cycle, there is no threat of it disappearing as an energy source. Fossil fuels are non-renewable. One major problem with our dependence on fossil fuels has to do with the fact that as non-renewable resources, they will disappear. There is a limit to these fuels, and they will run out. Another problem is associated with the burning of fossil fuels. Fossil fuels are polluting to our atmosphere. When fossil fuels are burned, gases and chemicals are released that can harm the atmosphere. The atmosphere is made up of a variety of gases, including oxygen, nitrogen, and carbon dioxide. It is the carbon dioxide in the atmosphere that acts like a blanket, helping to keep the Earth warm by trapping radiant energy from the sun. Radiant energy travels through the atmosphere, strikes the surface of the planet, and some of this energy is reflected back toward space. The carbon dioxide in the atmosphere helps to reflect some of this heat energy back to keep the planet at the right temperature to maintain life. However, when too much carbon dioxide gets into the atmosphere, the blanketing effect is increased, causing too much radiant energy to be trapped. This is called the greenhouse effect. You have probably walked through a greenhouse at one time or another and thought the temperatures were much higher than those outside the greenhouse. If we take 2 fish bowls outside and fill the bottoms with sand and then set them in the sunlight for a while, we can perform an experiment. Put a thermometer in each bowl and wait about a minute before taking its temperature. Then, place a sheet of glass on top of one of the bowls and wait about 15 minutes. Then compare the temperatures again. The bowl with the glass on top is helping to capture some of the radiant energy in the same fashion as the carbon dioxide in our atmosphere. So, as cars, trucks, factories, and power plants release more and more carbon dioxide into the atmosphere, this contributes to a buildup of greenhouse gases and increases the greenhouse effect. Another issue related to the use of fossil fuels is referred to as global warming. As the greenhouse effect has more and more of an effect on the atmosphere, the planet becomes warmer and warmer. Some scientists believe that this global warming could have far-reaching effects for the entire planet. Farm areas may become too dry to produce plants. Chemicals released from factories, power plants, and automobile exhausts also combine with water vapor in the air to create acid rain. Acid rain can travel in the atmosphere over great distances and then fall as precipitation. Acid rain can harm plants, fish, and even buildings and statues made of limestone and marble. Here's a demonstration to show the effects of acid rain. You will need 2 glasses, some vinegar, water, and a piece of chalk. Put some water in one glass and some vinegar in the other. Break the chalk in half and put one half in one glass and the other piece in the other glass. Now, watch what happens. You should see the chalk dissolving away in the vinegar. Vinegar contains a lot of acid. Chalk contains calcium carbonate, which is found in limestone and marble. So this demonstrates the effects of acid on some common building materials, limestone and marble. Currently, we depend primarily on fossil fuels for our energy needs. Fossil fuels are non-renewable, which means they will be all used up at some point. Fossil fuels are polluting our atmosphere because of gases and chemicals released from burning these fuels in car engines, factory furnaces, and power plants. To help protect the environment and to help ensure we have resources for the future, we must try to conserve energy. This means using less energy. It is something in which everyone can participate. Every little bit helps. Here are some things we can do to conserve energy. Turn off lights, televisions, radios, and other appliances when they are not in use. Use the dishwasher only after it is completely filled. Take showers instead of baths. Believe it or not, a shower typically uses less water than a bath. Consider public transportation and carpooling. Walk or ride a bike to the store instead of using the car. During the winter, turn down the thermostat and wear sweaters if you get chilled. Think about what you want from the refrigerator before you open the door. Recycling can contribute a lot to conserving energy. Many communities have recycling programs in place and require you to simply separate cans, plastics, and paper from the other wastes from your home. Energy is what keeps things moving. From forms of transportation to our own bodies, everything is dependent upon energy and the many forms it can take. Energy is the ability to do work. There are two types of energy called potential and kinetic. Potential energy is stored energy, or the energy of position. A skier is lifted by a ski lift to the top of a hill. This represents stored energy. When the skier turns and starts down the hill, the potential energy changes to kinetic energy, the energy of motion. There are 7 main forms of energy: mechanical, heat, chemical, radiant, electrical, sound, and nuclear. The law of conservation of energy states that energy is neither created nor destroyed. It changes from one form to another. Some energy may be lost to friction or air resistance, but the overall amount of energy stays the same. There are many sources of the energy we use every day. These sources of energy fall into 2 groups called non-renewable and renewable resources. Most of the energy used in the United States comes from non-renewable resources. These resources are called non-renewable because they are limited. They include coal, petroleum, natural gas, propane, and uranium. Renewable energy resources can be replaced, and in some cases are considered to be limitless. Examples of renewable resources include solar energy, wind energy, biomass, geothermal energy, and hydropower. Now it is time for the program quiz. There will be 10 questions that require short answers. Question 1. How are potential and kinetic energy different from each other? Question 2. What are the 7 main forms of energy? Question 3. The law of conservation of energy states that energy is neither created nor destroyed. What does this mean? Question 4. What are non-renewable resources? Give some examples of non-renewable resources. Question 5. What are renewable resources? Provide some examples. Question 6. What are some of the problems associated with burning fossil fuels? Question 7. Why are non-renewable resources also called fossil fuels? Question 8. How were fossil fuels formed? Question 9. Why is the law of conservation of energy so important? Question 10. What are some things people can do to conserve energy?